Okay, thanks. My name is Andrea Taramelli. I would like to thank the organization of the meeting that invited us. I'm here as a national delegate in the Copernicus Committee and the Copernicus User Forum. So we were asked to make like a sort of like two-step presentation. I'm sorry that I'm going to be in a rush because I have a train pretty soon, but I hope that I will give you an idea on first, what is the governance that Italy, as a member state of the Copernicus User Forum and Copernicus Committee, started to apply as a national policy to get out of the best from the Copernicus regulation. And in this case, then I will show you some few examples of what are like some use of different data set of the Copernicus services in case of supporting the maritime spatial planning and some coastal dynamic example. So I will briefly introduce that actually Copernicus is a program, so it's a regulation, and it's divided in two main core business, that is the services development and the space component. So Mercator Ocean and the CMEMS are part of the Copernicus services. So the Copernicus services are developing products and services at European level. Then, as was already said several times this morning, this kind of products and services has to be used and downstream, so at national and local level. And the regulation states that the downstreaming services has to be implemented under the space component, especially has to be developed under the ground segment development and operation. So in this program, Italy is in the governance of the Copernicus within the Copernicus Committee, represented by MIUR, ASI, and ISPRA, and by the Copernicus User Forum by ISPRA and ASI. I'm highlighting this because as a member state, Italy made like a big decision. So basically, as a part of the policy and the governance, it was highlighted that the national ground segment, in accordance with the European Union and the Copernicus Committee, will be an important way of getting downstreaming services. So basically, each member state, like Italy, France, and whatever, are bringing up to the European level, using this forum at Italian level, in our case, getting what is the user need and the user requirements that can be attached to what is the development under their core services. So the Italian National Copernicus User Forum, we would like to show what is the state of play. So he was founded and formally constituted in December 2014 in the frame of the interministerial working groups meetings. So the working groups aims to define the main national lines and orientation to maximize the national returns in terms of operational services offered by the Copernicus program. This is very important because in this user forum, there's like a big discussion about which are the user need and the user requirements that the member states, so Italy, would like to develop under the CMEMS in this case, but for all the Copernicus core services, of course. So why? In the frame of the working group was identified the need to share information and coordinate decisions about the ongoing and foreseen activities in the three Copernicus bodies. So in this frame, we, me and other people, as national delegates, we are bringing up to the European Union what are the user need and the user requirements as a member state. So the first step was launching, and it was done on the 27th June 2014. And in this framework, it started to have a mid-term objective of the National Users Forum was to stimulate and produce a qualified, authoritative, and coordinated national space policy in the program. So the basic issue is like, under the User Forum, we are taking all the user need and user requirements that we will, as a member state, we will bring at the core services level, but also at the user forum as the user need requirements to develop the downstreaming services. So the National User Forum is composed by representatives of public and research institutions, industries, and enterprise. So basically, this is the table where most of the user requirements and user needs at national level are discussed and then bring at European level, both for the core service development and for the downstreaming service development. This is, at least for us, really important because this table and this user forum is under the presidency of the ministry. So basically, the government would like to have the best out of the user requirements bring at the European level. So how much could be the return from the core services and also from the development of the downstreaming services? So this is a slide that was sort of the summing up of what was recently decided. So the Copernicus User Forum at national level is taking into consideration what are the user need for commercial operator, the user need from the institutional operators, and then how this can be function, and then is setting up a system where the downstreaming services attached to the core system of the Copernicus has to develop operational services for commercial user and operational service for institutional user. So basically, this is what, as a member state, we are bringing always with different requirements at the Copernicus Committee and the Copernicus User Forum. That's what all the member state does, always. So based on that, at Italian national level, we agree on the development of the Copernicus collaborative grant segment, where the national collaborative infrastructure is a sort of extended infrastructure that is going to use the distributed, already available scientific and private infrastructure that has to develop pieces of core services and of downstreaming services. So the central role of this collaborative grant segment in Italy is played by the Italian Space Agency. So the collaborative grant segment will be based within the Italian Space Agency. Then the National User Forum is related to this collaborative grant segment through institutional users, other public bodies, research and academic bodies, and enterprise. And you can see, and that's why we were invited, that regions and regional authorities play a key role in that. Of course, when we talk about user needs for institutional, we have to think about who is going to be the real users. And this morning I heard that there were some presentations that were talking about like intermediate user. So in order to develop real operational products for like managing coastal areas in this case, or like marine areas, region and national institution play a key role. Then research center, industries, and enterprise collaborate and integrate this kind of user needs. So as an example, I will show you what is a sort of a scheme that under the Copernicus Users Forum is used to develop some sort of user requirements and pre-operational downstreaming services. So in this slide, I'm showing like two different definitions. One is the new framework directive, that is the Maritime Spatial Planning and Integrated Coastal Zone Management. And then what is the definition in the regulation of the Copernicus program. In both, we can find that a key word is monitoring methods. In both, we find a similar challenges. So in the Maritime Spatial Planning, we are talking about future needs in terms of monitoring and development of indicators to assess the impact of climate change. The same applied with the regulation of the Copernicus. So future needs in terms of monitoring and development on an autonomous multi-level operational Earth observation capacity of EU worldwide. So in both, we have implications related to climate change, but also vulnerability, risk of, in this case specifically, I took some words from the regulation of the Copernicus related to marine and coastal environment. So CMEMS represent some of these keywords. So not going into detail. So I'm going to show some monitoring methods that we start to have as an operational tool using direct, so in situ data, indirect, so using Earth observation or modeling, and how we can integrate the different MEMS products with some in situ data and some modeling data. So what is the challenge if we look to the maritime spatial planning, but also on the Marine Strategy Framework Directive? So it's identify the nature and rate and consequence using new technologies to increase spatial and temporal resolution of the monitoring service. So that is how we can develop real downstreaming services that intermediate user and really end user can apply daily on their monitoring issues. So the idea is predict the consequence of climate change for our marine environment. So this will require the development and measurements of indicators. So just to sum up, we have to deal with scenario generation. So some example. In this case, we are doing an assessment and monitoring of critical events. So in the Northern Adriatic Sea, in this case, we are dealing with forcing of waves that are local winds. So we have two distinct wind regimes, Bora and Scirocco, that dominate the condition in the area. So this is the scheme that we elaborated under the user forum, where we have like 3 different steps with in situ data analysis, a model output, and with the in situ data analysis, we have a critical event identification. Then we use Earth observation product for validation and for data simulation within a model. Then we have a model output for the event interpretation and for a hindcast and forecast of critical events. So before the Sentinel were running, the best thing to do was looking at the data availability. So having the Sentinel under the Copernicus really made a big change. So in the first time, we had to do a pre-operational modeling using all the available data. Once the Sentinel are up, we saw that this problem is solved by the very high temporal resolution that we can get with Sentinel-1. So we use remote sensing SAR data to calculate wind and waves using SAR data, but not just calculating the wind and wave, but assimilating this type of data into a physical oceanographic model. So these are the type of data that we were using once the Sentinel were up. So we used in situ data mid-ocean climatic analysis to see if there was like critical events and how much was changing the trend of the critical events. And then we were looking in how many number of cases were popping up during the interannual season. So we estimated wind fields at fine scale from SAR satellite, allowing observation of morphology and patterns. So this is the estimated wind field and the domain of the area. So we use ASA wide SWAT mode and then Sentinel-1 to produce CMOD 5 along algorithm. So we use that to produce wind data that were validated with the AquaAlta platform in the Northern Adriatic. So we simulate reanalysis with SAR data and without SAR data. So we have 2 examples of some wave field force with reanalysis with wind and wind with SAR data on the left. And on the right, you have wind field with similar pattern between SAR data and reanalysis. So what we were finding out is that you can have like a better wave downscaling, in this case of the Northern Adriatic, using SAR data every 6 days using Sentinel data. So you still use oceanographic modeling, and then you reshape the wind and wave pattern using the SAR data every 6 days. Another test case was using, in this case, Sentinel-2 and the optical and multi-optical data, so model data, in situ data, and observation data. So we were producing total suspended matter. We were using river discharge, TSM, total suspended matter measurements in order to have a cross-correlation analysis and find a way for spatial and temporal defining patterns of total suspended matter, still in the Northern Adriatic. So we were looking for correspondence between total suspended matter concentration and specific physical forcing. So we were doing interannual analysis and intra-annual analysis of spatial variability of TSM and other optical water quality parameters. So we were applying empirical orthogonal analysis to figure out if you can have like different behavior or total suspecting matter pattern analysis. And the same we did with the empirical orthogonal teleconnection analysis. So we were using then this type of variables to make a cross-correlation with a hydroclimatic variable classification based on magnitude. So we were looking to different type of spatial pattern related to normal discharge, intense discharge, and flood condition. So what we were looking at if we can find a way to setting up a monitoring operational system for sediment resuspension event during intense wind stress. So we were still using also the wind and wave reconstructed by SAR data simulation, and we were correlating that with the evolution of sediment resuspension process. So what we saw that is the monitoring of sediment resuspension was basically correlated also with TSM and some particle settings. So we then make a step forward looking, we are talking about coastal areas, how much this cross-correlation could be influenced by coastal subsidence. So the comparison of significant waves, temporal total suspected matters pattern, and trend of subsidence. So we did that because we have a challenging in mind. So assess of current ecosystem service delivered, and how can we predict consequence on ecosystem services due to natural and man-made change. So we were producing scenario generation with some regulating service, so flood protection and erosion prevention of different natural habitat classifications. So we were using still some part of not CMEMS, but that was from land core services. So how can you use also habitat mapping and make it correlation? Right now, also there is also a big discussion at European level. How can you link between CMEM services and land services? So how much the coastal can be covered by the Mercator Ocean CMEM services and the European Environmental Agency land services. So we set up an ecological structure as a component on flood and erosion vulnerability analysis in deltaic and coastal zones. So we were looking to spatial pattern series, temporal trend series, goods and services, process and function. So we were setting up a fuzzy logic approach, so a model that we're considering a coastal vulnerability scenario using a fuzzy Bayesian approach. I don't go just too much deeply on that, but just to let you know that most of the hazard scenario were produced using the data simulation model using SAR, and then we were looking at the temporal, so as a critical events, and how much they were changing the TSM spatial distribution, and then we were setting up an habitat evolution time series to get temporal trends of distribution of sediments related to Scirocco and Bora events. So we were using the temporal empirical orthogonal function component of the sediment and vegetation compared with in situ measurements of tide levels in the same temporal series. So that was done then in order to look at the provisioning and regulation services using also the habitat mapping that you can find from the core services of the land, and then increasing as a downstreaming service with the spatial resolution of in situ data of high resolution radiometric, high radiometric resolution. So we were producing added value product as Natura 2000 habitat types and UNIS habitat types. So we were using the core services of the land, and then we were increasing the resolution. So we were making correlation on how much the habitat types were changing related to some critical event in the Northern Adriatic. So we were using a high-resolution classification, and we ended up to see how the habitat availability of like a specific bird was changing due to critical events. So how the nesting areas could be affected of specific event like Bora and Scirocco. Another example, still using a lot of like MEMS, is the toolbox decision process to make an assessment of marine aquaculture. So the toolbox process is using several parameters, both in situ and directly from the CMEMS. So we were using CDOM, chlorophyll, TSM, and then we were classifying specific coastal turbid water limit. And then we were using the current velocity, that is like a CMEMS ocean products, then water quality, sea surface temperature still from my ocean, and then using the toolbox, we were doing aquaculture suitability. So just to end up with an example, because we are in Liguria, we were using the Sentinel to set up a statistical model that was used to calculate the pressure on the Posidonia oceanica meadow of the leisure boats. So just to close, the Copernicus core services and the possible downstream services that you can set up can give us a better understanding of potential climate change impact. So the idea is that using the Copernicus User Forum, we are setting up a big discussion about which are the tools that can be set up by intermediate user and then used by the final user. So these are the acknowledgements. Thanks a lot.